Good morning, everyone. Hello, good morning.
Good morning, sir.
Good morning, sir.
Good morning, Samantha. Are you guys able to hear me, Rahul? Why Rahul is on mute mode today? Rahul, your microphone is not working, is it? Hello.
Yes, sir. He typed in the chat box.
Okay. So, give me a quick glance of what we studied during the last class. Basically, we spoke about probability, right? Are you guys able to see my screen?
Yes, sir.
Samantha, what about you?
Yes, sir.
Okay. So, in the last class, we basically spoke about inferential statistics, where we learned about probability, correct?
Yes, sir.
Okay, and one of the main concept in probability, that was normal, not normal distribution, sorry, the conditional probability, correct? We took about, we spoke about the example from sales perspective, where you find the probability of purchasing any of the vehicle given the number of conditions, correct?
Yes, sir.
So we also understood about complement of an event, an independent event, dependent events, right? And also we learned about few applications, like where probable conditional probability use, something like your categorization of the sports news or any political news. When it comes to customer feedback, whether it's a positive feedback or a negative feedback, or coming to facial recognition systems. Later, we spoke about random sampling and the concept of central limit theorem, correct?
Yes.
So now in the last class, we discussed on how the data points are distributed when you have a normal distribution. Let me come to presentation mode. You are able to see my screen, right?
Yes, sir.
Okay, so we understood that when your data is normally distributed, around 68% of your data will be in one standard deviation gap, and when you move two standard deviation from the center, you get 95% of your data, and when you move three standard deviation, you get 99.7%. And what happens when you move four standard deviation? Who can answer this? Shaina?
Yes, sir.
What happens when you move four standard deviation from the center? You cover almost the entire data, right?
Yes.
Okay. we did a small Excel workout where you have the coal prices. So we have 1000 entries in coal prices and we have 10,000 entries in gold prices. We found out the mean and the standard deviation, correct? And we use the small formula to find out how many points will be lie at what standard deviation. Now I need a volunteer. Who can volunteer? Samantha.
Yes, sir.
So this is your center, correct?
Yeah.
So if I move from here to one standard deviation, okay, what is this range be? I have this value. I know my mean. I know my standard deviation. How will I find it out?
Z is equal to X minus mu divided by.
See, what I have given is I have given a formula here. That
Okay.
is the number of points in all the points here. Okay,
Okay.
are greater than, that is C1 minus C2. What is C1? C1 is your mean. C2 is your standard deviation.
Okay.
That is mean minus standard deviation. All the points which are greater than this region
Okay.
and all the points which are less than this region. That is C1 plus T2. C1 plus C2 is here.
Okay.
Okay. Basically, we are talking the points which are greater than, which come under this region. Okay.
Okay.
So in this formula, I got out of 1000. Out of 1000, I ended up getting 680 points. That is within 68% of your data is in one standard deviation.
Okay.
Okay. And when I move to two standard deviations, you can see the formula here. You can see the formula here. What I did was, you are moving two standard deviations, correct?
Yes.
So you have covered almost 96% of your data points.
Yeah.
And when you move three standard deviation, okay, you're moving three standard deviation here, you're covering almost 99%. So let me move four standard deviation. A721006. You're covered almost 100%. You covered almost 100%. Is it clear? Shaina, is it clear to you?
Yes, sir. So where is the 006? And
Which one?
the formula only.
Okay.
You put double A1 0006 and 4.
Don't break your head on formula. You'll never get to work on this formula. This is just an example for you.
Okay, got it then, sir.
Okay. If you want to
Yeah.
go to this spreadsheet, this spreadsheet is already uploaded in your LMS.
Okay, yes, sir.
Okay.
Yeah.
And if you want to plot a histograph, okay. If you want to plot a histograph, so how do you plot a histograph for a categorical value? See, your data is here your data is not normal, here your data is categorical. How do you plot histograph when you have categorical data? We spoke about it, right? You have your apple, you have your banana, you have your grapes. This is how you plot it. Do you guys remember? And the frequency comes here.
Yes, sir.
Okay. But when you have the data in continuous form, what you do is you specify the range, the data point which lies in 30 to 40. How many data points I have? This is your frequency. I have something like 50 data. Then you have 40 to 50. Let's say I have 60 data. Then you have 50 to 60. Let's say I have 100 points. And when you plot it, your range that comes in your x-axis, and the number of frequency comes in the y-axis. Is it clear?
Yes, sir.
Yes, sir.
So similarly, in this histograph, what we have done is we have calculated the bins here. We have calculated the bins here. That is how, that is the data points lying 3 standard deviation. Then you have data points lying 2 standard deviation. Then you have 1 standard deviation. Then from the mean. Based on this bins value, bins are nothing but your range, what we just explained. Okay, based on that, how many points are lying in this particular range? This is the output we received. Now, is it clear to you on how the normal distribution is? How this normal distribution is?
Yes, sir.
Yes, sir.
Now, what is your mean value? That is 40.28. This is the mean value. Mean value is here. So once if I move 1 standard deviation, I'm covering 68% of the data. Correct? If I move 2 standard deviation, 95. If I move 3 standard deviation,
99.
almost you're completely 99%. If I move 4 standard deviation, whatever the balance were there, everything is covered in this. Okay. Now, coming to the next topic, that is called standard normal distribution. Now, if I want to standardize the data, okay. Now, if I want to standardize the data, the primary need is, why do I have to standardize the data? Why do I have to standardize the data? I have a plot here. Okay. This is a probability distribution curve. What is the area under this curve? What is the area under this curve? The area under this curve represents the probability of happening of an event, correct? If I consider the complete area, that is nothing but you are 100% confidence that that event is going to occur. That means the P is equal to 1. If I have considered only this half of the portion, what is the area under this curve?
0.5.
0.5, correct. So when you have a data that is in the range of 0 to 1, what happens is your data is in very standardized format. So if you have data in this particular format, finding the area under this curve would be really easy for you, because you will have a standardized format. You have standardized table where you can interpret the table and understand what the area under the curve is. So that is very clear when it comes to your Z-score. Okay, so Z-score, when you have a standard normal distribution data, so Z-score gives you the idea of whenever you have a Z-score, it gives you the idea of what the area under the curve is. You have the data readily available. Now the question is, how do you standardize the data? What is the formula for Z-score?
Z is equal to x minus mu divided by standard deviation.
Yeah, that is Z is equal to x minus mu divided by standard deviation. So what you're doing is, okay, this is your distribution. Okay, let's say that your mu value is somewhere around 700, or for we can use this example. We can say mu value is 40. Okay, now how do you bring it the mu value? So the property of Z-score, what is the property of Z-score? When you have property of standard normal distribution is your mean equal to 0, standard deviation equal to 1. You guys remember this?
Yes, sir.
Samantha, you're very silent today.
I have swollen eyes, so that's why.
Okay.
Allergy.
You didn't sleep last night, is it?
No, I have allergy with plants, these roadside area plants. I went out yesterday and that's why
Okay. So hope you're able to see the screen.
I'm able to see, but then it's still blurred, but that's it.
Okay. Okay. So if you want to bring your mean to 0, how do I bring the mean to 0? That is by subtracting all the values, subtracting all your values by your mean. So when you do that, what happens is your mean will come to this position, that is the 0th position. Correct? Rahul, are you
Yes.
able to speak now?
Yes, sir. Am I audible?
Yeah, you're audible.
Sir, I had issues with the Zoom, so I couldn't hear you from the beginning.
Okay, okay.
What you taught today, I couldn't hear you. Then I updated the app and rejoined.
Uh-huh. Okay,
And even I had issues with my microphone as well. So,
okay.
yeah. Now it's proper, sir. I can hear you.
You're able to see the recording, no?
Yes, sir.
Okay. Okay, so what I was explaining was, how do you standardize your data? Okay, so the formula of Z-score is nothing but your x minus mu by sigma. So mu is your mean and sigma is your standard deviation. So the range of your standard normal distribution 0 to 1. So how do you bring your mean value to 0? That is by subtracting all the values by your mean. So that is how you bring this to 0. But once you bring this to 0, do you have the standard deviation of 1? Let's
No.
do that exercise. Okay, so what we will do is, let us go divide, let us subtract each and every value with mean. Okay, I have subtracted each and every value with mean, and then I will find what the mean is. Now mean is 0. What will be the standard deviation? It is 2.45. The standard deviation is still the same, but only I have managed to bring the mean to 0. Now how do I manage to bring the standard deviation is to 1?
By dividing it.
You have to divide by the standard deviation, correct? So what I do is, I divide this by my standard deviation. Now my standard deviation is 1. Is it clear, you guys?
So mean will be 0, right?
Mean will be 0, but here you have something like minus 4 to the power 10 to the power minus 18.
Okay.
It's nothing but more or less 0 only, right?
Yeah.
Okay. Now, if I were to plot this, how does the data look like? How does my plot look like? I have to define the bin. How do I define? That is nothing but, how do I define the bin size? Rahul? Oh, you are not in the class.
No,
Shaina, how do I define the bin size?
So bin size means the range, right?
Bins is nothing but your
It's like the grouped data.
no. This is for this. Your data is sorry, continuous, right?
Yeah.
So when you draw a histograph, nothing like your x-axis, like you have to define the range. Like in this particular range, what is the data lying? Something like that.
Okay. So it's not
Maximum
class
minus.
interval, selected values.
So yeah, what you have to do is you normally use a formula like mean minus 3 times, then it comes 2 times. Like you start with the mean, okay? From the mean, you move 1 standard deviation, then 2 standard deviation, 3 standard deviation. Whereas
Got
here,
it, sir.
your mean is 0, correct? If you're moving 3 standard deviation, your 1 standard deviation is just 1. If you're moving 3 standard deviation, it will start from minus 3.
-3, -2, -1.
Minus 3, minus 2,
Minus 1, 0,
0, 1, 2.
1.
Correct?
Yes.
Now
Sir,
I'll
so
plot my,
always there will be 7 values.
yeah, Rahul?
Always there will be 7 values.
Not particularly, since your data is almost 99% of your data is covered in 3 standard deviation.
Yeah.
You're not stressing on that. If you want, you can specify more bin values also.
Okay, sir.
So this is how your histograph looks like. Okay. So this spreadsheet is already in your LMS. If you want to try with more bins, you can try it with that example. Yeah, and similarly, you can try for gold here. Now, for gold prices, you have around 10,000 entry points. You can play around with this, and you can learn more about the distribution. Okay. Now, let us work out a small example. You guys able to see the screen, right?
Yes, sir.
Yes, sir.
Yes.
Now, to understand why your standardization of the data is important, so let us work out on a small example. Okay. Now, the beauty of standard normal distribution is that when I standardize the data and all the data points are in one place, that is called Z-score, the table what I showed you earlier. Now, based on the Z-score table, I can find the probability of each point. Like, let's say that if the point is lying after 2.5 standard deviation or 4.5 standard deviation, I can find out all the Z-scores. Let's see a working example. We have your baggage loading, correct? Now, in the airport, you have that baggage loading, right? When you go to an airport, you drop your check-in baggage and you are allowed to carry only your cabin luggage and you can go towards security check-in. Correct?
Yes, sir.
Yes.
So, when you drop your baggage, is it that as soon as you drop your baggage into the baggage check-in counter, does it mean that suddenly it will be loaded into your flight?
No.
No.
There will be some delay, right?
Yes.
Even while loading into the flight, you can see that many of the ground crew, they are trying to load your baggage or there will be some delays. Correct? Even after boarding, you have to wait a couple of minutes just for baggage to load and get it started. Now, the manager wants to know what is the probability that it will take more than 22 minutes to load the baggage. Okay. Now, why do you think this is necessary?
To maintain the time gap.
Correct. You have to maintain the time gap because in airport you have number of flights coming one after the other, right? So you have to maintain that time gap. So first thing what you do is you have your data points. Based on the data, you have your mean and your standard deviation. So you find out the Z-score. But before I find out the Z-score, just by seeing at this data, you can identify what the probability would be. Correct? If you are smart enough, you can identify directly. How is that?
Using bins.
When you have a normal distribution, okay, let's say this is your 22 minutes. Now the manager wants to know what is the probability that flight will take more than 22 minutes. Like he wants to find the area here. Correct?
Yes.
Yes, sir.
Now this is your 0. This region is your 50%. Correct?
Yes.
Basically, in terms of frequency, he wants to find what is the probability that the point will be lying in this particular region. What is the confidence interval that point will be lying in one standard deviation? That is nothing but your 68%, right? Earlier, I taught you that if you take a normal distribution and you move one standard deviation to the left or to the right, 68% of your points will be lying in this particular region. Now go the other way. If I select this region, there is 68% probability that the point will be over here. Correct? Is it
Yes.
clear to you guys?
Yes, sir.
Yes, sir.
Coming to this example, what is your mean plus standard deviation? This is 18.5.
18.5.
What is mean plus 2 standard deviation?
22.
That is 22. Okay. That is, what is the probability that the point will lie in 2 standard deviation?
95. 94.
95%. Okay. But you want to see the probability of the point lying after, beyond 22. That will be the 5%. But 5% could be here, could be here. Correct, Rahul?
Yes, sir.
Ideally, what will be your answer?
2.5.
2.5% is the answer. Do you have to do all this exercise to find out? Just by looking at the data, you can immediately guess the answer, right?
Yes, sir.
Yes, sir.
Okay. Now, if you want to do it practically, what you do is you find out the Z score. How do you find the Z score? That is, X is 22. minus 15 by 3.5.
Oh.
This will be 7 by 3.5. You get 2. Correct?
Yes.
Now,
Yes.
if you have to find P of X greater than 22, what you have to do is you need to find Z greater than or equal to 2. So you need to find the value of Z. For that, that is for the Z value, for the Z value of 2. I think the chart is cut out here. For the Z value of 2, you get an answer of 0. You get this particular value. But Z value will give the answer of this region. It always gives you the answer from your central value. Okay. So what you have to do is, you know that the area under the entire 50% of this curve is your 0.5. So you subtract the Z value, you get the answer as 22.8. So earlier, whatever answer we got, that was 2.5%. Here you got 2.28%. So before you do all this calculation, you have already guessed the answer. Clear?
Yes, sir. So there
Yes,
are different tables, right? Some will be from minus infinity onwards. So we can refer any tables, right, for Z value.
No, you have to refer from a Z value for your standard normal distribution.
Yeah, but there will be some tables like in PU while we studied, we had from area from Z, area from 0.
Okay.
Some had from something minus infinity onwards. But the answer, final answer will be same, sir.
Will be same. So you don't have to worry about the Z score itself. Python will automatically do it for you. Okay.
Okay, sir.
You don't have to break your head. I'm just giving you the idea how exactly you get the values. Okay.
Yes, sir.
But ultimately, what you have to know is you have to learn how to interpret the values. Okay. So coming to the first question, why do you think the manager was keen on finding this value? Let's say that on a daily basis, you have 1,000 aircrafts, okay, boarding from the same gate. Okay. So if the flight gets delayed, so from Airport Authority of India or any airport authority will apply heavy dues or heavy penalty on the aircraft which delays its takeoff. Okay. So he wants to understand what is the probability that a flight will take more than 22 minutes. Okay. Let's say that he has kept 22 as his threshold. He wants to find how many flights get delayed more number of times. Let's say that you got 2.5%, let's say 3%. Okay. What is the 3% in 1000? 30 flights, right? Let's say that for each flight, you are getting a penalty of 1 lakh. So you're losing 30 lakhs per day, correct? Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
So that is like we have to multiply the probability with the total number, right?
Correct.
To
See,
get the
you get the
exact.
answer as 2.5%. Somewhere consider it as
Yes.
2.5%. If the 1000 number of aircrafts are working on every day on one particular flight, I mean one particular boarding dock or something. So what is 2.5% of your 1000?
25.
Around 25 or 30. Okay,
Yeah.
consider on 30 flights. Okay,
Yes, sir, understood.
then you calculate what are the penalties. Now suppose if the management says that I will allow not more than 15 minutes for the luggage to load, and you find the probability of, I mean you find the mean itself as 22. Okay, from your data, that means all the flights are getting delayed, correct?
Yes, sir.
What would you do at that particular scenario?
They need to decrease the time. That is, they have to make
That
the
means
luggage
your whole
loading.
process, whatever the luggage loading process is, their whole process is wrong. You have to change your process, correct?
Yes, sir.
Because if you are dealing everything, that means almost 1000 flights you're paying 1000, I mean you're paying 1000 lakhs, correct? Can a airline work if they pay like 10 crores every day for the delays?
No, sir.
No, right?
No. No.
Okay, is it clear to you guys?
Yes, sir.
Yes, sir.
Now coming to the last topic, that is hypothesis testing. So instead of going into the concepts, let us go with an example of a court case. How does the court start? Has anyone been to court?
No, sir.
No, sir.
No, right? You might have seen in movies, no?
Yes, sir.
Yes.
Now let's say that you have a case in hand, and there is accused and there is a victim. So, okay, so the proceeding will start with
Prosecution.
that is the accused saying not guilty. There is a victim, there is an accused. The accused, the proceeding will start from the scenario, from a what you say, from a hypothesis. Okay, from a hypothesis saying the accused is not guilty. Okay, after that, after this, each party, the party from accused, the party from your victim, will keep providing the proofs to their to the court to prove their point, correct? Are you guys with me?
Yes, yes.
Okay. So till sufficient evidence is available at the court, the judge will say that ultimately when the judge will give the final hearing, what will the judge say? Judge say that on the basis of evidence, correct? On the basis of evidence, correct? Based on the evidence given by, so if a judge has found that the accused is guilty and under the section so and so some punishment is going to announce. Do the judge use the word I or say that I am 100% confident that accused is guilty?
No.
No, right?
No.
So the court believes in hypothesis testing. The court believes in your initial hypothesis that the accused is not guilty. And until the sufficient evidence is produced into the court will be believing in the your null hypothesis. Once you have the sufficient evidence to prove that the accused is guilty, only then the court will discard the null hypothesis and select the alternate hypothesis. That is only when the court has the solid evidence to reject this. Correct?
Yes, sir.
So hypothesis testing is basically the interpretation of your math. In the world of, let's say, manufacturing, I use the same concept. If I have n machines, machine 1, machine 2, machine 3, machine 4, machine 5, so my null hypothesis says that I manufacture 75 grams of dairy milk. Okay, but the question is, this is my ideal condition. So at what point I should, I mean, after what point my output is not 75 gram? There should be a checkpoint, right? So when I say 75 grams, do I expect all my machines to manufacture 75 grams?
No, there will be ups and downs.
Correct. So I'll be saying 75 grams plus or minus your standard deviation. So any machine, based on what we learned in the past, any machine that is going, let's say, greater than 3 standard deviation. Okay, let's say the machine, your standard deviation is plus or minus 0.02. So what is your allowable limit? This is 75. Let's say this is 75.02. Let's say that you're not going to allow any machine that is manufacturing more than 3 standard deviation. Tomorrow you get a machine from China and you get the ice cream, I mean the chocolate weight as 76.5 grams. You reject this machine, right?
Yes.
Yes, sir.
Your null hypothesis is you allow the machine to produce this particular weight of chocolate. But this doesn't work out with your, even the Chinese machine. What you do is you assume that it's going to produce this much, you manufacture it, then you test it. While checking the weight turns out to be more. That is when you choose, that is when you reject your null hypothesis and you choose your alternate hypothesis. That is, what is the alternate hypothesis? Your machine is not manufacturing 75 grams. Correct?
Yes, sir.
Yes.
Okay. So the same concept, there is a statistician called Ronald Fisher. So he is a great leader in when it comes to hypothesis testing. He came up with the idea to test the hypothesis. That is, what he did was he made two varieties of tea. That is, T1 is you boil the water, pour milk. Everybody knows how to make tea, right?
Yes, sir.
Yes.
Yes.
So in T1, he made 4 cups of tea. That is, he boiled water and added the milk. Okay. In the second trial, what he did was boiled milk and then added water. Okay. He thought it is impossible to make out the difference. So he called a lady to differentiate it. So his null hypothesis. What was his hypothesis? What is this assumption?
No difference.
Yes, it is here. The lady had no ability to distinguish the teas. That is his null hypothesis. Okay. He called this lady and he asked her to randomly taste the tea. He has randomly kept all the cups, and while tasting, what happens is, what is the probability of getting 1 cup right? Getting only 1 cup right, the probability is more or less? Out of 8 cups, getting 1 cup right is more, right?
Yes, sir.
Yes, sir. Yes.
2 cup right? Little less. 3 cups?
Less.
A little more less. Correct?
Yeah.
So he thought it was impossible to make the difference, but to his surprise, the lady was able to predict all the 8 teacups correctly. Okay. Therefore, he had to reject the null hypothesis. So the point here is the lady was an tea tester. Okay. And that is why it was not fluke that she identified all 8 cups correctly. The chances of doing some fluke was for all the 8 cups was very, very low. So what? So ideally, what you understand is your null hypothesis should have your expected value. What the values you expect from an outcome, and rejecting the null hypothesis is good or bad. When you have expected values in your null hypothesis, rejecting the null hypothesis, is it good or is it bad?
When we have expected values, we have to accept the hypothesis.
Yeah, it takes a great amount of evidence. It takes a great deal to reject your null hypothesis, right?
Yes, sir.
So when it comes to null hypothesis, all you have to do is you need to, in null hypothesis, you will have your expected behavior, and your alternate hypothesis, it will be not expected behavior. So the moment you get solid evidence to reject your null hypothesis, that means that something is wrong with your system. Correct? Now let us see this example, one more example. So this should be good enough for us to understand null hypothesis and alternate hypothesis. So keeping everything same, you know this game called baseball, right?
Yes, sir.
Yes, sir.
Okay. So keeping everything same, what are the chances that the team winning at home versus winning abroad? This is the concern. So sometimes it is same as cricket. If India team is performing cricket in India, plus versus India team playing the cricket somewhere in Dubai or somewhere in England. So where do you think they have the more advantage of winning the match?
Home ground.
Home ground, India.
Home run, right?
Yeah.
So here we go with the alternate hypothesis. I mean, we go with the hypothesis saying that there is only 50-50 chance. So keeping everything the same, the chances of winning the team at home versus the team winning at abroad, that is 50-50, considering everything same between all the teams. Now the question is, the chances of winning at abroad is 50, and while you are calculating, you end up chances of winning at home is, you end up with 60%. Ideally it is 50%, but you end up getting 60%. Now there is a small doubt in your mind that the team is having home field advantage. Okay, is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Let's say that instead of getting 0.6, you got 0.8. Okay, now is the doubt more or strong now?
It's strong.
It is strong. 0.8 out of 1 is very strong. Okay, similarly, we conducted an experiment to understand, does this particular team has a home run advantage? Okay, so there was this team who was playing baseball. We wanted to calculate the particular team has home field advantage or not. What we did was, we took a sample of 2431 matches. Okay, and ideally the winning probability was assumed to be 0.5. You want to see out of how many matches, out of these 2431 matches, how many matches they have won. So after calculating, you got the probability, let's say P as 0.5381. Okay, now based on your ideal condition, you are expecting the probability somewhere here, correct? 0.5. But based on your calculated value, it has come 0.5381. So how far is this too far? You need to understand using the Z score. You calculate using the Z score. Don't worry about the formula. You get the Z score as 3.76, and ultimately you got the probability as very, very, very low. So that is, there is almost impossible event that there is no home field advantage. Correct?
Yes, sir.
Yes, sir.
Yes, sir.
Definitely the team is having home field advantage. Have you guys heard about the concept called Six Sigma in manufacturing?
I've heard, but I don't know what exactly it is.
Okay. Technically, the concept of Six Sigma is that is, in manufacturing nothing but you build a perfect system. So ideally, our question was, to what extent the management can accept your limit compared to your ideal limit, correct? So that is nothing but your Six Sigma. What you do is, all your data points, whatever you in manufacture, or whatever the data points you covered in a manufacture, ideally all your data points should lie between 6 standard deviation. That is 6 standard deviation from your left and from your right. Technically, if you go on the right way, it will give around 3.4 rejections per million pieces. For 10 lakh pieces of, let's say 10 lakh pens you manufacture, you will have only around 3 or 4 pens rejection. Is it clear? I'll give you one more example. Let us take the example of your airport example, what we did. Okay, so this is your dream airport, where this is your allowed loading time. Okay, is it clear to you guys what example we discussed earlier? Now this is your airport 1, where you have mean is 22 minutes. Mean loading time for your luggage is 22 minutes. Okay. Now, if the company had told that anything after 1.7 standard deviation, if the company had told that I will not allow anything after 1.7 deviation, but your constantly your average is around 22 minutes, correct? Now the company says that anything above 1.7 standard deviation, that is 15 plus 1.7 or 15 minus 1.7 times the standard deviation. So in our example, what was our standard deviation? Standard deviation was somewhere around, anybody able to recall? Let's say I think it was 3.5.
3.5, sir.
Correct. So how much will be 15 plus 1.7 standard deviation? Who can calculate and give me the answer?
So 21.125.
Okay, 21.125 is the answer. If the management says that I will not allow anything beyond 1.5 standard deviation, that means this is your threshold. This is the maximum limit you can go. But if you're getting constantly 22 minutes of your luggage loading time, correct? Will you allow this particular time?
No, sir.
Will you continue with the present working process in
No.
your new airport? No, right?
No.
No.
You have to change all your airport procedures because something is wrong here and constantly you're losing money. So while arriving at this, you are already focused on your null hypothesis, that is my airport is behaving in this particular time frame. But you ideally, when you found out the time was more, and you have to reject this hypothesis. Is it clear? Any doubts?
No, sir.
No, sir.
No, sir.
Now, during this calculation, you always came with the p-value. Okay. Now the application point of this p-value in your data science comes when you work on time series. Okay. So in your time series, there is a concept called as stationary. So there's a concept called as stationary. So what you do is, in order to test this stationary of your time series, you do a test called as ADF test. The full form is augmented Dickey-Fuller's test. Okay. So by default, your null hypothesis is the data is H0 is not stationary. This is your null hypothesis, and you perform this test. So here the threshold given for P is 0.1. Okay. So what ADF test does makes you do is, you do conduct the test and you check the p-value. Okay. Either you go with the threshold or you reject it. So now if the p-value is less than 0.1, you disagree that it is not stationary. Okay. Is it clear? Shaina?
Yes, sir. Yes.
Okay. So ideally null value says that it is not stationary and you keep your threshold as 0.1. If you go below 0.1, you have to reject your null hypothesis of the time series being not stationary, because the time series is stationary now. If the p-value is, let's say, 0.15, then you have to accept the null hypothesis that it is not stationary, and you have to do certain corrections in your series in order to make it stationary. So later down the line, when you work out on time series, it will be very clear to you. Okay. Now, what we can do is, it's 12 o'clock. We can take a small break, and after coming back, we can start with NumPy.
Okay, sir.
Okay.
Yes, sir.
Okay. Now the time is 12 o'clock. We can come back at 12:10. Will it be okay?
Yes, sir.
Okay.
Yes, sir.
Let's start. Is everyone back?
Yes, sir.
Yes, sir.
Rahul?
Yes, sir.
Okay. So do you guys have any doubt in statistics?
No, sir.
No, sir.
Even if you understand all the concept very vaguely is also fine, but you will have to clarity once you start with the analytics. Okay. Now let us take a big leap to understand the two important and very popular packages in data science. One is your NumPy and the other one is Pandas. So in the previous classes, we had studied descriptive and inferential statistics. So descriptive is where you will be starting to apply immediately, whereas inferential is something you will use later down the line in machine learning. So as inferential is all about predictions. So your NumPy, what is the full form of NumPy? NumPy stands for numerical Python. Okay. NumPy stands for numerical Python and Panda stands for panel data analysis. Make a note of this. So basically these two are Python packages. Okay. So would you guys tell me the benefits of packages by any chance?
And they help us in solving the problems related to a certain topic.
Okay. Any other definition?
There are special. There will be specialized codes for the analysis.
Correct. So the important aspect is, should I break my head focusing on the nitty gritty of writing a perfect code, or should I break my head on solving the business problem? If I understand this point very clear, then you will have the right answer. Correct?
Yes, sir.
Yes.
Okay. So let's start with the package called NumPy. So before I start, I'll just show you this code. Okay. Can anybody tell me what is the code doing? You have two functions here. Okay. Let's say that this is function 1 and this is function 2. Can anybody tell me what function 1 and function 1 are doing? So the function 1 is your pure Python version. Okay. What I'm doing is I'm defining a function here. You guys remember the function called range, right? Do you guys remember the function called range?
Yes, sir.
Okay. So size of vector I have given 10,000 here. 10,000, sorry, the 10 million. Okay. I have given 10 million here. No, 1 million, sorry. I have given 1 million here and I have given the range. Okay. And list 2 also I have given the same. So list 1 will be identical to list 2. What I'm doing is I am adding both the lists. Okay. Correct. Ultimately what I'm doing is I am seeing the time taken for Python to do these operations. That is creating first list, creating second list, adding both the list. So what is the time taken to do all these operations? That is the time difference. Basically, I'm interested in the time difference here. Correct? Is it clear?
Yes.
Yes, sir.
Can anybody tell me what is the values stored in this my list, either my list 1 or my list 2?
From 1 to 1 million.
It will be 0 from 0, right?
From 0 to 1 million.
0 to, it can't be 1 million. It will be 9
The
lakh
maximum.
99,000.
Yeah.
Correct?
One less than the value.
1 less than, yes. Now, the problem with list is, can I add both the list directly?
No, sir.
You cannot add both the lists directly, right? I have to do the iteration. Either I have to go for list comprehension or I have to go with iterations. Like I had to iterate over one after the other element. I had to add them manually. Correct? Coming to the NumPy version. Okay. In NumPy, similar to your range function, in NumPy we have a range. Both the functions are similar. There is no confusion in it. Okay. But the advantage of NumPy is that you can directly add it. This is the advantage. You don't have to iterate over it. Correct?
Sir, here the values will be stored in the form of arrays, huh?
Correct.
Okay.
Since NumPy you're not aware of, you have to first import it as NP, because this is the alias given to the word NumPy. You can directly use NumPy dot everywhere, or you can use NP dot everywhere. Okay. So I have NP dot arrange function. I create 1 million points, and all I have to do is I have to do array1 plus array2. Okay. And I calculate the time output, I mean the time difference, in the same manner. Okay. So practically speaking, NumPy is around 50% faster. It's showing 75%, around 50% faster than your other version, your Python version. Okay. The question is, why is it faster?
Because in NumPy the values are stored in arrays, so the calculation will be faster.
So NumPy has a very customized way of operating numbers. What Rahul said is also true. Python was made in a very generic in nature, very generic way, but NumPy is a very specific nature. Basically, it is prime motive was to your numerical analysis. Okay, the underlying code in NumPy is written in C. Even in Python, it is written in C, but it has layers. We have different layers, so that's the reason why it takes little more time to calculate, because it will not be in direct form. So now that you know NumPy is faster, let us learn few more things about NumPy. Basically, in order to use NumPy, what you have to do is you cannot directly use it, you have to import it. Okay. So in Python, how do you calculate average? How do you calculate average in Python? We use mean, right? We use mean, correct?
Yes.
Yes, sir.
I think mean is in math function. Okay. Anyway, we'll not break our head on it. But in NumPy, you have a function called as average. Okay. you have a function called as average to calculate the mean. Okay. So NumPy is a package that was primarily built to analyze real world numerical data. So the moment I talk about real world, there is a special reason for that. How many of you guys seen real world data in a form of a list? Let's say that you have a list like employee record 1, then you have employee record 2, employee record 3. It will never be in the form of a list, right?
No.
We usually see the real world records in the form of tables, in the form of tabular form. Correct? So we are more aligned towards data in tabular form than in the list form. So in tabular form, the data could be in dimensional form, like it could be your 1 dimension, it could be your 2 dimension, it could be your 1 dimension, your 2 dimensional, or 3 dimensional. So NumPy is generally generalized as your ND array, where n stands for a number of dimensions. Okay. But when I talk about real world data, does it always be in numbers?
No, sir.
Correct. There'll be categorical inputs also. Correct. But what we are trying to do is we are slowly trying to move towards the problems in real world. Okay. Now, for ND array, who can give an example? It could be like a single dimension, like your employee ID 1, 2, 3, 4. Correct. It is a single dimension. Now for the 2D array, who can give an example?
Matrix.
It will be like your employee ID and your employee name. This is your 2D, the most generic type of array in real world. Okay. Coming to your 3D array, you have your employee ID, you have your employee name, then you have your address. But under address, you have line 1, line 2, okay. And also in your address, you have like pin code. For suppose for pin code, you further you have into the area code and location code. Correct. So with respect to human point of view, is it easy to idealize this data or visualize this data? No, right? It's little difficult. But with computer perspective, what it does is, when you have your address, it will store something like this in layers as shown here. So for the computer perspective, with computer perspective, do you think this is weirdly out of the world concept? No. Is it clear to you guys? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
So you see that you have gone level, that is like 3D. Now when you have levels, okay, let's say that employee ID, let's say that employee age, then you have address, in that your address line 1, line 2, then your pin code. Further this is divided into your area code and location code. Okay, this type of data is very difficult for you to visualize. So what you do is you rather leave it to computer to deal with it. So NumPy is suitable to handle this type of data. So this is the whole reason why we started with Excel sheets. Now slowly we will get over Excel sheets and we'll try to find if I could completely transition towards NumPy and Pandas for all my work. So that the day you become more comfortable, the more compatible understanding, if you have the day you become more compatible in understanding these packages, NumPy and Pandas, that is the day you will be much smarter in data science. Okay, because Excel will limit the process of a thought process. The moment you get flexible in NumPy and Pandas, your analysis will be more and more scientific and powerful.
Okay, sir.
Okay. Now, coming to the concept of list and your array. How will you find the data type in list? You use the function type. Okay. Now, in NumPy, you don't use the regular list. You have something called as NP array. Okay. You are going to convert the list into your one-dimensional array, and when you see the type, you get NumPy ND array. Is it clear? Rahul, is it clear to you?
Yes, sir. So we just have to type enter type of the variable name, right?
Correct. Type function. You have already studied this.
Yeah. So this functionality is similar to the normal Python code.
Correct. Type function is very similar.
Yeah.
Whenever you use NP here, that means
Ah.
it is a derived function from your package.
NumPy. Okay.
Okay. Now, if you have an array like this, okay, the visibility is very poor. It will be very difficult for you to understand. Something like this. So this is a two-dimensional matrix, or you can say it as it's a matrix. It's a two-dimensional list, or you can call it as a matrix. How do you differentiate it?
There is a list inside a list.
Yeah, how do you differentiate it? How do you understand it's a two-dimensional?
Through the brackets.
Through the brackets, yes. Basically, you understand how many opening.
How many
brackets
opening and closing are.
Correct. So when you convert the same thing into matrix, into your array, you get this nice looking matrix output. Correct. So the list is a type of data that is very difficult to understand and analyze, whereas your ND array gives you very good reliability also to read the output. Okay. Now, if you want to see the type, you get ND array. Okay.
Sir.
Yeah.
So whenever we are using NumPy package, we have to use an extra variable, right?
Extra variable in the sense?
Here, like normal, when we use a variable, it will have it will undergo the coding of Python, right? So to display the numpy thing, we have to use, like here it is my underscore mat. So to display, we use just mat, another variable, right?
Nothing like that. You can define it inside also.
Okay.
What you can do is,
So just if we type np dot array of mat, then also it will get displayed, right?
correct.
Without using the
You can
extra
define, you
variable.
are defining np dot array. Okay.
Ah,
And inside the bracket, you can define whatever the variable directly, and you still get the output.
okay, sir. So there is no rule that we have to use another variable.
No, no, no.
Okay.
Ultimately, you will not be like using to define any variable. You will be deriving the data from the data itself, right?
Yes, sir.
Something like each column data or a row data, correct? Your data will be already there. You will be deriving it here just to make you understand with the examples. We are defining the junk variables. Is it clear?
Yes, sir.
Okay. Since now you understand the concept of ND array, let us see what other attributes does this NumPy has. So the first attribute is I can call about, let me see if I define array. Array is here. The first attribute is dot shape. Okay. What it does is it will give you the shape of the array. So it will be defined in terms of row and a column. Okay. Why do you have a comma here? Rahul? Why do you have a
Okay.
comma here? Shaina?
So is it because it's a list?
It gives output in the form of a tuple.
Okay. Since the brackets are there.
Correct. Okay. Now, see, this is for your basic list, and here that is for your ND array, where it gives you number of rows and number of columns. Correct?
Yes, sir.
And you have one more function called as n dimension, NDIM. This gives you the number of dimensions in the array. Okay, this is one dimension because it's having only one row, whereas this is two dimension because you are having row also and column also. Correct? Now, if you want to understand the type of a variable, you use the type function. Correct? Are you with me?
Yes.
Yes, sir.
Okay. Now, if I want to understand what is the type of the value that is inside this particular variable, that is inside the list or any array, what function will I use? Python doesn't have that function, but NumPy has. Okay, the function is .dtype. It will give you the data type of the variable which are stored inside the array.
So it means if there is a value inside a list, it will give the data type of the variable.
It gives you the data type of the variable.
Okay, sir.
Something like you have a list here. Okay, if you give list dot d type, okay, it will give the data type of these values. Now here it is giving me int because I have all the integer values, and whatever the 32 is, that you just ignore it because it gives you the bit size of your computer. Okay, you don't have to worry about it. You just focus on the int type, integer value type.
So
Why
we
this
can
is
consider,
important?
sir,
Why is this important? Why this function is important?
to know about the specific variables.
Okay,
Uh,
I'll tell you. Rahul, you're asking some doubt, no?
So we can enter their specific value, sir, like a list of two or list of three, something like that.
Whereas here,
Yes,
right?
sir.
Why don't you try it out? You can try it out, no?
Because when we have mixed data,
Correct. Let's say you have your data here. Let's say serial number, and you have a column called as age. Okay. Now, when you use this function, the age column, basically it should throw an output as an integer, right? Are you guys with me?
yes, sir.
Yes.
But this data type, it will show as an object. But that is not something you were expecting, right? When you want to tabulate this age column, let's say that you want to calculate the year of birth. Okay, when you have the age, what you have to do is you have to multiply the present year minus the age, but you cannot do any operation on it because this is object. Object will not allow any mathematical calculation on it. It should be in the form of integer. That is when you know something is wrong with this column. Either there could be some junk values or there are some missing values. Correct? So this is a trick. From this particular d type function, you can understand. Let's say that you have 10,000 entries in a particular column, that you can understand that something is wrong with this column. Correct? Or if you directly went on calculating and suddenly you'll understand that why this calculation is not happening, because you have spent so much time on your coding, understanding about the data. Finally, the tabulation is not happening. It is throwing value error over here. Ultimately, you have to come back and see what the data type of this particular column is. So instead of doing all that, you can use this function to understand what the data type of this column is. Is it clear to you guys? Samantha, is it clear to you?
Yes, sir.
Okay. Now, I spoke about shape. In the similar context, can anybody tell me the use of this particular function? Samantha? Samantha, are you there?
Yes, sir.
Let's say that you have a data. Okay, you've been given a data. What is
Okay.
the first thing you're interested to find out?
The heading. Number, the size.
You'll be interested to find out how many rows. Correct? How many
Yes.
rows are there? How many columns? Is the data sufficient? You'll be interested to find out that. You'll be interested to know what is the shape.
Yes.
Let's say that you have 7 columns, and let's say that you have 10,000 rows. You will be
Okay.
interested to know this, correct? Before even working on each and every column to understand what is happening in the column, you will be interested to find what is the size of my data,
Yes, sir.
correct? That is where this particular function comes into picture.
Rows and columns.
Correct. This function is very, very important for you, for everyone.
Okay.
Okay. Now, I spoke about range function earlier, right? In Python. Python, you have a function called as range function, but in NumPy, you have a function called as a range, correct? There is not much difference between these two functions. So the only difference is that the list gives you, let us put it here, range of value 5. Let's say list 1. Okay, let us use the same concept. Okay, you have, it gives you in the form of a list. Okay, whereas np.arrange, what it does is it gives you in a clear array type of a list, correct?
Yes.
And the
Yes,
last number, what it specifies is generally it specifies your step size, correct?
Yes, sir.
yes, sir. If
Now,
nothing is specified, it will increment 1, right?
correct. Now, where is this concept used generally? Let's say
To
that,
generate.
let's say that okay, now ignore that. I'll give a list. Let me say, okay, I have a list here and I have okay. Now, where is this concept of list and array used? Let's say that these are the employee salary in a company and company suddenly decides to give a bonus of 20%. Okay. Now, if you have a list, can I do this? Can I do this? No, right? But when I have my array, correct? So company is giving 20% bonus to everyone. I have the array and array of salary of everyone. What I have to do is I have to just multiply by 20%. Immediately I have the package to everyone. Are you guys with me?
Yes, sir.
Yes, sir. So
Yes.
here it will not see the data type.
Not the data type. Here the problem is, if you want to calculate this, what you have to do is you have to iterate over the list.
Yeah.
Correct?
Here it is in the form of array, so directly it undergoes.
Directly it will happen.
Okay.
Okay. Now, if I want to create an array of zeros, you have a function called np dot zeros. It will give a array of zeros. Correct? So, but if you look closely, Python, I mean, if you look closely very here, just to be safe, it typecasts the array into float. Correct? You have 0 dot something. Is it clear? Now, let's say that I want to have an array of zeros with integer values. How do I do it? I use np.zeros, the same function. I have a function called dot as type, and in as type I define it as int. Now I have it in integer. Correct?
So why it can point something in the first case?
That is the basic typecasting technique which Python is written on. The NumPy, basically a NumPy package is written on.
So whenever 0 comes, it comes with a point.
Correct.
Okay.
So you
With
have
other
to-
numbers, only if it is a decimal point, it will come, right?
correct.
It's a decimal. Okay.
Always your Python typecasts any integers into float type, data type,
Whenever 0 comes.
not just 0. np.1s, even your np.1s also comes in that way only. See,
Okay. When we give this code like np dot something.
yeah, basically in order to create any matrix, let's say that you want to create a matrix full of zeros
Okay, sir.
or a matrix full of ones. You have inbuilt functions like np.zeros or np.ones. Inside the bracket, you specify the, what do you specify? You specify the shape.
Yes, sir. So for specific values, we can generate a matrix.
Correct.
Okay.
Now, anybody has the idea how do you specify, how if you want to make a unity matrix, like let's say you want to make a identity matrix. What is the function you use? There is a function called np.I. EYE, you get identity matrix. But in all the three cases, all the data variables are in float data type. Correct? Are you guys with me?
Yes, sir.
Yes, sir.
Yes.
Okay. Now, there's one more famous concept in time series called as linspace. Okay. This is a very interesting concept. Let's say that this is my data. I want to divide it in 4 equal parts. Okay. How many points will I have? How many points are required to divide this particular data into 4 equal parts? This is my starting point, 25th, 50th, 75th. How many points are there?
5.
5 points.
5.
Correct? Now, linspace actually does it for you. Okay, what it does is generate 10 points between 0 and 5. This is your starting 0, this is your ending 5. But how many points you need? You need 4 parts or 5 points. Okay, what it does is it gives you the 5 equal points. Oh, sorry, 10 equal points. You have a line from 0 to 5, correct? But you want to divide it into 10 equal points. Let's say that 0 to 100, you want to divide it in 4 parts. You get how many points? 4 points.
4 points.
Or you want to divide it in 5 points. How many you get?
5.
So where is it used? Where do I actually use it? That is the question here. So the primary use case is your plot. Let's say that you want to put some data. Let's say that you have to do some plot and you need the points here from 0 to 100. So based on this, I can define my x-axis, correct? While defining the x-axis, I want equidistant points. So for that, I can use this particular function. Is it clear?
Yes, sir.
Yes, sir.
Okay. Now, coming to another interesting concept in NumPy, that is called your random numbers. Why do we use random numbers?
For probability.
For probability, for your testing, correct? Randomly
Yes.
you generate few points, then you test it, correct?
For a sample, we usually generate.
Correct. So in NumPy, you have a function called random.rand, and inside the bracket you specify how many random numbers you need. You get the output. Okay. But what you can do is inside the function, if you see the definition, if you give Shift tab, you get this definition, right? If you look closely, this is the constraint inside it. Can anybody explain what does the square bracket and the flower bracket indicates? I mean the round bracket indicates.
The values will be between the limits. Like the values, the random values will be starting from 0 and it will be less than 1. So
Correct.
any values between 0 and 1.
Correct. What details I want to guys have to note down is you need to be very clear on this. Square in the sense including. Okay. If this is bracket, that means excluding or less than. Okay. Many of you get confused in this. I have seen many guys getting confused in this. There are some more ranges where I would like you to keep it in mind. The first point is, what is the range of normal distribution?
Minus infinity to.
Sorry, standard normal distribution.
0 to infinity. 0 to 1, sir.
This is your 0. 0 to 1 is your 68% probability of lying any point inside it. Correct? You go 2 standard deviation.
95.
95. You go 3 standard deviation.
99.
97. 97. What if I go 4 standard deviation?
99. 100.
Almost 100, right? Equivalent to 100.
Yes.
So the range of your standard normal distribution is -4 to +4. Correct? The second point, what is the range of correlation? What is the range of correlation?
-1 to +1.
Correct. It is -1 to +1. We'll get more deeper into correlation aspect later. Correct. Now, the third point is, what is the range of probability?
0 to 1.
It is 0 to
1.
1. Okay. Make a note of all three. Correct. Whereas here, it says random.rand function can give you 0, but it will never give you 1. It will give you all the values which are less than 1. I mean, between 0 to less than 1, it will never give you 1. That is what it specifies here in this round bracket. Is it clear to you guys?
Yes, sir.
Yes.
Samantha, is it clear to you?
Yes, sir.
Hope it's not too confusing.
No, no, sir.
Okay. Now, when I defined phi, it gave me 1D matrix. When I defined 2 cross 2, it gave me 2D matrix. What is doing is, the first is your column size, correct? Normally it should be row size, but for 1D it shows like a column. Whereas if you, let's say I want 3. So first is always your number of rows, and the second one is always your number of columns. Whereas here, basically it should come one below the other, but it shows something like this. Anyway, don't break your head on that. Now, just to give you an example, this function gives you value somewhere from 0 to 1, whereas rand n, what is n stands for? Return a sample or samples from the standard normal distribution. That means you have your standard normal distribution, what I explained earlier, the values are predefined. So all the values are built inside this rand n function. So when I ask random values in the form of 4 cross 3 matrix, it will give me all the values in standard normal distribution, junk values, basically. Is it clear to you guys?
Yes, sir.
Yes, sir.
Yes.
Okay. So I have made a small example here. I made a small example like what I showed you in the Excel sheet. I have defined 10,000 random variables under standard normal distribution. Okay. After defining it, I take the average. What is the average of your standard normal distribution?
0.
0, yes. Then it calculates the standard deviation. What is the standard deviation?
1.
1. Then, interestingly, what I do is I'll check how many points are in the one standard deviation difference. Oh, sorry. Here I checked 3 standard deviation. Okay. I get it as 99. If I want to find one standard deviation, how do I do it?
-1 to 1. -1 to 1.
Yes. %68. Correct?
Yes, sir.
In Excel, I took a lot of head breaking and a lot of plots to understand it. I got the values in just one line of code. Correct?
Yes, sir.
You guys able to understand what this is?
Yes, sir.
What the code is?
Yes.
Now, in the same fashion, what I did was I used a small trick here. The trick was I didn't have the data. So since I didn't have the data, I had to improvise. Improvise on what? On the coal prices. Okay. What I did here was, what is 2.1?
Standard deviation.
Standard deviation of what? Your coal.
Cool.
Plus 40. What is 40?
Mean of the coal.
Mean of the
Average.
coal. What I
Yes.
did was, using the concept of random standard normal distribution in random numbers, I went back to get these numbers. Okay. And I plotted them. How does the plot looks like? Your normal distribution.
Yes, sir.
Correct? Here what I did, this is just importing. Okay. I use 3 lines of code to get the data, and I use 1 line of code to plot the data. Correct? Now, do you believe that Python is more powerful than Excel?
Yes, sir.
Yes.
Yes.
And also in the same concept, I have used my concept of central limit theorem. If you guys look very closely, how many times I have conducted the experiment? 100 times, 0 to 99. Okay. Each time, each experiment, what I did was I have taken 500 numbers in my normal distribution. Okay. Correct?
500 is the sample size, sir.
500 is the sample size.
Okay.
But how many times have I taken random sample of 500?
100.
100 times.
So it's
So
like
what-
capital N is 100 and small n is 500.
Correct. So I will explain you this concept in one more window. 1 minute. My Zoom is blocking my window. Okay. This is an interesting concept what I'd like to show you in, let's say tossing a coin. Rahul, I believe you have seen the class recording, no?
I've seen the half recording, sir, not the full.
Half recording. Okay, fine. So I was trying to prove the concept of, what is the concept? Central limit theorem. Correct? So the concept is very simple. Let's say that you have 10 coins, okay, and you toss it. The probability of getting head is 0.5, tail is 0.5. Correct, Rahul?
Yes, sir.
But you do this exercise practically, you will not end up with the same answer. You might get something like 0.9 or 0.8 heads or 0.2 tails, something like this.
Yeah.
But why do you think this is the ideal concept? How did they arrive at this? That is by conducting the experiment multiple number of times. Correct? They conducted the experiment multiple number of times to understand what is the expected behavior. It could be like your, let me clear it. It could be from here, whereas you're having 0 heads, 10 heads, 0 tails. You have all the tails here. Then you have 1 head and 9 tails. Then you have 2 heads and 8 tails. 3 head and 7 tails. Correct?
Yes,
something
sir.
like this. This is your most expected behavior where you have 50-50 probability.
Yeah, 5 heads and 5 tails.
Correct. Now, what I do is I would use 10 coins, okay, and I'll do this tossing 50 times. Correct. So what is happening is it is taking the random tossing and I get the values. Let's say that I do 200 draws. So total I have done 200 into 10, 2000 times tossing. Okay.
Yeah,
How the behavior is? Behavior is
normal.
normal distribution. Correct. So if you guys want to visualize this, I'll just copy the link here and paste it to you guys so that you can use it. Okay. Is it clear to you guys?
Yes, sir.
Okay. On the
Yes,
same
sir.
concept, I have used the same concept here. What I have done is I have used 100 experiments. That is 100 experiments, and in the each experiment, I have used 500 points. Okay, and I converted back to our regular data. That is the coal prices. If you see here 39, 39.8, 40, if you come back and see, you get 37, 33, 39, 40, 41, something like this. The data is same now. And then what I did was I picked the data and I plotted histograph. Ultimately, what I did was I got the normal distribution. Okay. Now, before I finish this particular, I have a small concept here. Now, you are aware that we can make random numbers like using this function. Let me say that I have to make random numbers of one dimension. Okay. Now, Python has one more inbuilt function called as reshape. Okay. So this function allows you to reshape your array into different form. But ultimately, you have to take care of the number of variables inside it. Since you have 9 variables here, the reshape, whatever the dimensions you're going to give here, it should match with the initial declaration, or else you'll throw an error. Correct? Are you guys with me?
Yes, sir. But the values will vary, right? For
It
each
will
and
vary.
every.
They're random numbers.
Yeah.
Don't worry about the values. As I said, random numbers are used to experiment, to test.
Okay.
You only focus on the concept.
Yes,
Here
sir.
the data might vary, but when you're working on the actual data, the data will not vary. You will be using the same concept, right? You will be using the same values.
Sir, is there any way we can freeze the value? It's just like copy paste, right? We can't do anything else.
I have frozen the values here.
Okay.
Correct? I have frozen the values here.
So we take the values and we store it in a variable.
Yes. That is how you freeze it.
Yes, sir.
Okay. Let's say that I define a random variables of 16, size 16. If I say that this 16 I want in 3x3 matrix, will I get it?
No, sir. It should be 4 cross 4.
It will be 4x4. 4x4. Okay. Now, what are the other ways of reshaping it?
2 and 8.
2 and 8, or 8 or 2. Correct?
Yeah.
So this is for you have converted the single dimension data to 2-dimensional data. Correct? How do you verify it? Dot Sorry,
D type.
dot D type. Sorry, dot.
So DIM.
Dot dimension.
DIM. Right?
I give DIN, is it? Wait, let me just go back and see. N dimension,
NDIM.
NDIM. It's two-dimensional. Correct?
Yes, sir.
This is one dimension. Okay. So let us pause for today, and in the coming class, we believe we can complete NumPy and then move into pandas. And I believe you guys have to practice a lot. Most of you guys are not practicing, I feel. Weekly, how many hours do you guys spend on practicing?
It depends, sir.
Minimum?
I think minimum 3 hours, I guess. 2-3 hours.
Minimum 3 is more than enough.
So I'm not finding this NumPy document.
NumPy document is available.
Yeah, when I couldn't find it that time. Or in which folder?
NumPy and
I got, sir. NumPy and pandas separate folder is there, I guess. I could open this.
it is in here. NumPy and pandas course content. Under course content, you will find the zip folder here.
So I tried opening it, but then I was not finding any content inside.
You have to download
It
it.
shows a blank. I
Then we
downloaded
need
it,
to
sir.
extract it, no, sir.
If you click here, I believe you will get this particular type, and here you
Yes,
have
sir.
this one. No?
Yeah, I downloaded it and then pasted it in data science folder.
No, before that we need to extract
You have
it.
to extract it.
Oh, okay, okay.
You need
okay.
to have WinZip or any other unzipping folder, unzipping software.
Oh, okay, okay.
You can use WinZip or 7-zip. Okay. So if anybody
Okay.
has any doubt, you can stay, or others can drop off.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, Rahul.
Sir, henceforth we'll be using the Zoom platform, sir.
I wanted Zoom platform because it allows me to use Teachpad also, because while explaining certain concepts, no, I'll have to write here itself.
Okay, okay.
So that's why I used. Next week we'll see based on the availability, which is more compatible for you.
For me, Google Meet, because I'm using it from last year for my normal regular classes.
Mm-hmm.
Not that much used to Zoom, but it's fine, sir. With Zoom, you're finding it very easy, so no problem for me.
No problem. No? Okay.
Yeah, we can continue with Zoom, sir.
We'll continue. I'll update you if I want
Yes.
to use this.
Yes, sir.
Okay.
Thank you, sir.
Thank you.